Hi, my name is Eduardo Ox. I'm the author of an Emacs package called EV, and the title of this video is Some Problems of Modernizing Emacs. Here is a summary of the main themes of this video. I'm going to talk mainly about these four things here. The first one is that Emacs have changed a lot in its recent versions, and now it has lots of types. So if we want to look under the hood and to understand what Emacs really does, we are going to stumble on lots of types, and the current tree of classes and types looks like this. That is quite big. The second theme is that people used to say things like anyone can learn Lisp in one day. I'm going to explain this quote, and I'm also going to show that now this is gone. Anyway, this is a very short summary. Details soon. I will also show how to display better inner views of Emacs objects. I'm going to define what is an inner view, of course. The main trick is that we are going to use one of the ways of displaying internal objects, that is the CLPrint family of functions, for example CLPrint1 to string. And here are some examples of the kind of output that we are going to see. For example, if we run these two lines here, the first line defines a function foo, and the second line sets O to the internal view of the definition of foo. In older Emacs, O would be just a list that would look very similar to this line here, but in newer Emacs, the result of this, I mean the contents of O, is this thing here that looks quite different from this definition here. So in older Emacs, the contents of the function cell of of foo would be a node style lambda that would be just a list like this, and in newer Emacs, the contents of O would be a vector like lambda. Looks for the square brackets here. This is a vector, but it is preceded by a hash sign. So this is what we call a vector-like lambda. And vector-like lambdas do not have a canonical printed representation. They have at least two semi-canonical printed representations. The first semi-canonical printed representation is this one. It's generated by a family of functions with names like print1. And the second semi-canonical printed representation is like this. It looks like a list, looks somewhat like this definition of foo here, but it has this dynamic bind symbol here. And it turns out that when we use the CLPrint family of functions, we can reconfigure how things are printed. And I'm going to show several interesting ways of reconfiguring how lambdas are printed, and one of the ways is going to be like this. We can also use the CLPrint functions with my indentation tricks to display how types or classes are viewed internally by Emacs, and this is a big example. This is what Emacs considers as being the definition of the type CL structure class, and it is this big thing here. I edited it very lightly. I just deleted some line breaks here. And another thing that I want to explain is that Emacs has some help functions that I have never liked. For most people they are good enough, but for me they aren't. They are, well, I'm going to say more about this later. And for example, if we want a description of what is this type here that we just saw in its internal view here, we can run either describe type or my variants of describe type, and we get a help buffer that looks like this, in which these blue things that are underlined are buttons in the classical sense. You can click on these buttons or type return on these buttons, and you will be taken to another help page that is generated dynamically, and you can navigate back and forth and, well, whatever. And I'm going to explain my problems with these kinds of help buffers and what I'm trying to do to overcome these problems. One of my slogans in this video is going to be this one: anyone can learn Lisp in one day. And this is a part of a bigger quote that I took from a keynote presentation by Abelson and Sussman, who are two dinosaurs of computer science. Here is the full quote. Anyone can learn Lisp in one day, except that if they already know Fortran, then it would take 3 days. This is a frame of the video. And by the way, I am going to add this. And if the person is starting with DOM Emacs, then it would take 5 years. Why? I'm going to explain why. This is how Emacs Lisp used to be. If we execute these two expressions here, the first one is, each symbol can have two values. One is the value as a variable, and another one is the value as a function. If we run this, we store 42 in the value cell of the symbol foo, and if we run this defun here, it stores a certain anonymous function in the function cell of the symbol foo. In Emacs, until some time ago, if we did that and if we run this expression here, the result would be 42 because of this line here, and if we run this line here, the result would be the anonymous function corresponding to this defun here. But now this have changed. The result of this thing here is this vector-like lambda here, but that doesn't matter much now. So until some time ago, if we did that and if we run this expression here, foo, Emacs would do this. It would replace the first foo by this anonymous function here. It would replace the second foo by the value of foo as a variable, that is 42. And it would evaluate this, and the result would be 420. So again, we used to have this slogan here: anyone can learn Lisp in one day, but now this is gone. Let me talk a bit more about why. The title of this slide is Lambdas for Beginners Broken. And if we run this, as I've shown in the previous slide, in the old style, in older Emacs, where the result of symbol function foo would be this anonymous function here, and now we get this strange thing here. So this is an old style lambda. This is a vector-like lambda, and until the middle of 2024, beginners could learn a lot of Lisp by thinking only in terms of objects like this. So this is a function, and this is an anonymous function, and they would learn how to draw const cell diagrams like this thing here and this thing here. They would think on lists as being these trees here, and they would be able to understand a lot of Lisp just by thinking in these terms. And then vector-like lambdas started to appear in many places, and if we use vector-like lambdas as in the wide sense to mean all the new objects these new objects that are difficult to visualize, they also started to appear in many places. This is a continuation of the previous slide. This part here is a copy of things that were in the previous slide. And before 2024, beginners could open black boxes like this. They could try to see what was in the function cell of the symbol foo, and they would see something elegant and mind-blowing, and they would start to love Lisp immediately. Now what they see is a tiny part of a very complex structure that is very powerful, but it's very difficult to understand, and now our beginners are overwhelmed instead of mind-blown. Note that I said black box here. Let me explain the term. We can open what's inside of foo. We can open foo to see the contents of the symbol foo, and we can try to see what's in the function cell of the symbol foo. So we can open the box, but what we get is something very difficult to understand. And so I'm going to say that when this happens, that box is black. It's not totally black. We can open it, but we don't understand what is going on there, so we declare that that is black. And when these things started to happen, I was overwhelmed. And in this video, I'm going to pretend that I was not the only person that was overwhelmed by these new structures that are not so elegant as the one that we had before. Anyway, before going ahead, I need to explain how technical this video is going to be. I hate videos that present things that look fantastic, but that are very hard to install. And I've been experimenting with things that can be installed, usually in /tmp, so in a very temporary place, in seconds. So they don't even leave garbage in your system. So in the page of this video, there will be something like this. You just need to copy that to a temporary buffer and execute that with a series of F8s, and then the rest will hopefully be somewhat obvious. This part here will download 3 files into /tmp, and these things here will show some tests. Let me execute these tests and explain what they do. I will need a smaller font. If we run this code cd, we just make this prefix here point to /tmp. We're going to put that in the list of in the load path, and then we're going to load my new definitions of clprint for some default Lisp objects. And with these new definitions, if I run this, it shows, well, this is my file 2025 modernprints.emacs Lisp, and it has lots of tests. And if we execute this test here, we are going to see that when we run this setq here, it shows the result of the contents of the function cell of ADT2, and the default representation is this thing here that is very ugly, but we have other ways of inspecting that. The first way is the default way. We just ask Emacs to describe what is the function ADT2. And it shows that ADT2 is an interpreted function that has 2 advices, whatever that means. And if I run this thing here to show my redefinition, one of the internal representations of CL of ADT0, the result is this. That is quite pretty. This is an internal view, a nice internal view of an advice object. And if we load this file here, modern reset, it resets the definitions of cell print to the default ones. So if we run this and we ask Emacs to print the contents of ADT0, we are going to get this. So it is indented in a weird way. It's not easy to understand, blah, 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 blah. But we can load modern prints again to use my new definitions again. And this thing becomes pretty again. And with these new definitions, we can also print, for example, the definition of a class. And this is exactly what I've shown before, except that we need to delete some line breaks here to make things slightly easier to read. But whatever, let's go back here. And I was also mentioning my problems with the Emacs help pages. This file here loads some functions for exploring these help pages and its buttons. And we have some examples here. Oops, sorry. Here. Let me show this example here. First, I'm going to define a structure called myButton. The name is bad, sorry. And if we ask Emacs to describe this structure in the default way, it says that myButton is a type that has these fields here and whatever. And this is the buttons that I don't like. And if I execute this thing here, that is a piano roll macro that I explained in a previous video, this thing here is going to simulate that the user is typing all these keys here. And please pay attention to what happens here. We are going to switch to this window, and then we are going to type a series of tabs to navigate between the buttons. We are going to stop at this button here, and we are going to do something, and this something will appear here in the mini buffer. So take a look here, then here. And now we defined a variable called eButton, and it points to this position in this buffer. And this file here has several tools for exploring these buttons. And the best way of exploring these buttons is to use this other function here that also sets this variable, but that shows some functions for exploring these buttons. Let me show it. It will do something very similar. It will navigate to this button here, and then it will execute find eButton links. So look now here. It creates this temporary buffer here, and these functions that start with find tree a button, they divide the window in the max frame in 3 frames. They show the help buffer here. Remember that the cursor is here on the button that we are trying to understand, and they show some other output in the 3rd window here. So this first call here shows what this button calls. For technical reason, this is the prefix for that is help. So the help call associated to this button is this one. If we format it in a slightly different way, it is this. And if we print the contents of a certain big structure and displayed it in this window, we see that the text properties at this position are all these ones here. They are sorted in alphabetical order. And then, sorry. We can delete the ones that are not very interesting, and we get this. So this gives us a lot of information about this button here, but it deletes some things that are not very interesting. And here we can see how we can extract the help call from this button here. The help call, it is this thing here. It calls the describe function with the argument CLPrint object. And we can see here that the help function associated to this button here is describe function, and the help args are this list here, CLPrint object. And the other things are not very hard to explain, so I'm not going to explain them now.